Good evening, sir.
Why so many less people are there today? Where is everybody? They will join. Aram se. Let us continue. We were discussing a very important sum. Question number 9. Part 1 we have finished. What was the question number 9? Find the lateral or the curved surface of a cylindrical petrol storage tank that is 4.2 meter in deep and 4.5 meter high. How much was it? What was the answer for question number 9, first part? What was the answer that we found?
59.4 centimeters square.
59.4 meter square it must be. 59.4 meter square. Yes or no? Yes or no? Because the dimensions are in meters. Check. The dimensions given are in meters for the petrol storage tank. 4.2 meters and 5 meters. Yes or no?
Yes, sir.
Now, see what they're saying. How much steel? Very important question. Huh? Very important concept to be understood. Pay attention very carefully. Let me first write down the question and then we'll discuss the question. How much steel was actually used if 1/12 of the steel actually used was wasted in making the tank? Means what you know? Now pay attention. All of you pay attention here. Very important sum this is. You know why important? Because the concept is important. Was actually wasted while making the tank. Now see what I'm saying. Suppose this was the rectangular sheet, है ना? Which was further rolled like this, correct? To make a cylinder like this, something like this. Yes or no, children? We are making a petrol storage tank.
Yes, sir.
Huh? Now, it is a closed tank. That means how much steel will be required for this? That is equal to the total surface area. We need the closed tank to be made. Yes or no? Yes or no?
Yes.
Am I audible?
Yes, sir.
Huh. So, how much sheet would be required? Sheet required would be TSA equal to the total surface area. But what they are saying, 1/12 of the steel actually used was wasted while making, means while bending. Sometimes it might have got cut, or during welding some portion was cut, some portion was polished to make it a smooth tank. So little bit of thing was wasted. So suppose this small little part at the end, this much part was wasted, in cutting, in welding, and all this part was wasted. Means suppose total X meter square sheet was used, then 1/12 was wasted. Means what? 1/12 of X of this total part. Means, see, if the total sheet, if I divided it into 12 equal parts, 2, 4, 6, 8, 10 and 12. this one of the 12th part was wasted. Yes or no? Are you understanding? One part was wasted.
Yes.
So how many parts are utilized? 11 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 parts are used to make the TSA. Means what? 11 out of 12 of X is equal to the TSA, and 1 out of 12 of X is equal to the wasted part, and 11 upon 12 of X plus 1 upon 12 of X, that is a total. 12 upon 12 of X, that is a total, becomes X sheet. Are you understanding?
Yes, sir.
So if 1/12 is wasted, means 11 upon 12 part is utilized for making the sheet, for making the cylinder. Are you understanding?
Yes, sir.
Ah. So
Yes.
let me write like this. Let X meter square of sheet was actually used to prepare the tank. Let X meter square of sheet was actually used to prepare the tank. 1/12 of the sheet was wasted, means 11 upon 12th part of the sheet was utilized to make the tank. Yes or no?
Yes, sir.
Therefore, 11 upon 12, 11 upon 12 fraction of X is equal to TSA of the cylinder. So ultimately it becomes 11 upon 12 into X is equal to TSA means what? Curved surface area plus 2 circles. Yes or no? Curved surface area plus 2 circles. Am I right?
Yes, sir.
Correct. Put the values, get the answer. So X, that is the total sheet, is equal to, or 11 upon 12 times X is equal to 59.4 plus 2. 2 circles means what? 2 pi r square. So I'm putting the values. 2 into 22 upon 7. How much is the radius? What they had given to us radius? 4.2 diameter. 2.1 was the radius. Yes or no?
Yes.
21 upon 10. 21 upon 10. 7 ones are 7 threes are. 59.4 plus 22 twos are 44. Do it. And 21 threes are 63. 3 fours are 12. 3 fours are 12 and 1 13. 0. 6 fours are 24. 26. 2 7 7 2 upon 100. So 2 decimals. 59.4 plus 27.72. Yes or no?
Yes.
87.12. 11 upon 12x. So x is equal to 87.12 into 12 upon 11. 11 ones are 11 sevens are 77.10. 11 nines are 99 and 11 twos are. So 7.92 into 12. 12 twos are 24. 12 nines are 102 plus 10, 110. 84 and 10, 94.04. So ultimately x is equal to 94.04 meter square. Yes or no?
Yes, sir.
Are we understanding, children?
Yes, sir.
means, see now, the straightforward meaning of this is, you know what? The total sheet was 94.04 meter square, whereas the TSA was 87.12. Okay, 87.12. If you check out 94.04 divided by 12, what are you going to get? 7.92. That is, this much part was wasted. This 7.92 meters were wasted. Remaining 87 were used, plus 7 were wasted. Total, it became 94. Are you understanding now?
Yes, sir.
Right. So write the answer statement. I will write the answer. Have you understood this part, all of you children?
Yes.
So write the answer statement like this. We'll write the answer statement like this. All these rough calculations and all those things should be very, very clear to yourself. How you are calculating, what you are calculating, how you are getting the answers. So now I'm going to write like this. Thus, a total of 94.04 meter square of sheet was used, out of which 1/12, that is 7.92 meters was wasted, and remaining 87.12 was the TSA, actual TSA. Of the tank. Correct? Actual TSA of the tank is 87.12. Correct? But that is what 11th out of 12th part. So the remaining one part was 7.92. So that 87.12 plus 7.92 was 94.04. Are you understanding, children?
Yes, sir.
So very important concept. 1/12 was wasted, means 11 upon 12 was utilized. And what was the utilized part? Equal to TSA. So 11 upon 12th part of X is equal to TSA. On cross multiplying, X comes out to be 94.04. Am I right?
Yes, sir.
Finished writing, all of you?
Yes, sir.
Question number 10. Lamp shade is to be covered with a decorative cloth. The frame has a base of 20 and a height of 30. Margin of 2 point is to be given for folding it over the top and bottom of the frame. Find how much the cloth is required. So let me take question number 10. The frame of a lampshade is to be covered with a decorative cloth. And how is the frame of a lampshade? That frame is cylindrical. That frame is cylindrical. We have seen that the frame is like this. This is the lamp shade. मतलब जो अपना टेबल लैंप वगैरह रहता है ना, उसका कवर है ये. उसको डेकोरेटिव क्लॉथ बनाना है. We have to make a decorative cloth for this lamp shade. For this lamp shade. Then what they are saying? Has a diameter of 20 centimeters. Diameter is 20 centimeters. What should I do if the diameter is 20 centimeters, children? What happens if the diameter is 20?
20 upon 2.
So radius becomes 10. And the height is how much? 30 centimeters. Height is how much?
30
30
centimeters.
centimeters.
And what else do we need? See what? An extra margin of 2.5 centimeters to be given for folding it over the top. This decorative cloth which I make, I have to fold it at the top, also at the bottom. And how much do I have to fold? 2.5 centimeters at top, 2.5 centimeters at the bottom. Means 30 plus 2.5 plus 2.5. Total, it has to become a 35 centimeter wala cloth. Yes or no?
Yes, sir.
And how much cloth is required now to cover this lampshade? How much cloth is required? You tell me.
TSA of the lampshade.
LSA. Why TSA? Why TSA? Lampshade we are covering. Children, we are covering the lampshade. तो टॉप एंड बॉटम तो खुला रहेगा ना. आप बल्ब कहां से डालोगे अंदर? वो बल्ब का लाइट कहां से
Yes,
आएगा
sir.
बाहर? Yes or no?
Yes, sir.
The top and bottom has to be empty, so only the side of the lamp has to be covered. And while covering the side, I want little bit of margin to be, you know, ऐसा ऊपर से उसको fold करना है मुझे ऐसे, you know. Suppose this is my let me show you. Suppose ऐसा अगर lamp रहा मेरा, ये है ना, table lamp रहता है ना ऐसा, तो ये जो मेरा cover रहेगा वो ऐसे थोड़ा ऊपर से मैं fold करूंगा, so it fits properly. So that 2.5 centimeter at the top and 2.5 centimeter at the bottom for folding. So 30 plus 5, total height would be 35, and the cloth required would be the lateral surface area of the lampshade. Yes or no?
Yes, sir.
So let us write. Very easy. Now the question becomes very easy once we understand how much cloth is required. Okay. The cloth required to cover the lampshade would be equal to LSA, CSA actually, lateral or the curved surface area of the cylindrical lampshade. CSA of the cylindrical lampshade, considering the extra margin required for folding. Considering the extra margin required for folding. Yes or no?
Yes, sir.
So, for the cylindrical lampshade, diameter is equal to 20 centimeters. So radius is equal to 10 centimeters. Height is equal to 2.5 plus 30 plus 2.5. That is totally 35 centimeters. Yes or no?
Yes, sir.
Cloth required is equal to CSA is equal to 2 pi R H. Yes or no? The CSA of a cylinder is 2 pi RH. 2 into 22 upon 7. Radius is 10. Height is 35. 7 ones are 7 5s are. So 2 5s are 10. 22 into 10 into 10. Yes or no?
Yes.
2200 centimeter square. 2200 centimeter square. Am I right? Yes or no, children?
Yes, sir.
2200 centimeter square is going to be 2200 centimeter square. I guess the last question now, question number 11 of the exercise. The students were asked to participate in a competition for making decorative pen holders in the shape of cylinders. Let me first take the questions. Decorative pen holders in the shape of a cylinder with a base using a cardboard. So to make one pen holder, we need a pen holder with a base. Means what all things do we need for one pen holder, children? What is the cardboard required for one pen holder? Okay, am I audible now?
Yes, sir.
Yes.
Yes, sir.
Okay, now let me again paste the question. What they are saying. The students were asked for to participate in a competition for making decorative pen holders in the shape of a cylinder with a base using a cardboard. How much cardboard is required to make each pen holder? Tell me. To make one pen holder, how much cardboard is required? Arey, tell. Children, am I audible? Am I audible?
Yes,
Yes,
sir.
sir. Yes, sir.
Just a minute. What they have said, you have to prepare a cylindrical pen holder such that it is a cylindrical pen holder with a base so that you can keep the pens. So how much cardboard is required to prepare one cylindrical pen holder?
CSA plus base.
Base circle, CSA plus one circle at the base, correct?
Yes, sir.
And likewise 35 competitors are there. So total how many pen holders are to be made?
45.
So into 35, yes or no?
Yes, sir.
Right. Chalo. So let's start writing. Solution. For the required pen holder, cylindrical pen holder, for the required cylindrical pen holder, what they have given to us, radius is equal to 3 centimeters. Height is equal to 10.5 centimeters. Let me write. Cardboard required for each pen holder. Cardboard required for each pen holder is equal to CSA of the cylinder plus what?
One circle.
Circle at the base.
Like
Yes, one circle at the base. You are right. Is equal to 2 pi RH plus pi r square. Or let me write it properly. So you tell me now, what should I do as the calculation part? Two pi RH plus pi r square. Can I take out pi r as common?
sir.
2h plus r. Am I right?
Yes, sir.
So 22 upon 7 into 3. 2 into 10.5 plus 3. So this is 66 upon 7. How much is 2 into 10.5? 21. That is 66 upon 7 into 24. Don't do the calculations. Likewise, how many do we need? 35. Yes or no?
Yes, sir.
Total 35 such pen holders are to be prepared. So cardboard required for 35 such holders is equal to what? 35 into 66 upon 7 into 24. Yes or no? 7 ones are 7 5s are 5 into 66 into 24. Do the calculations fast. Get the answer. Tell me how much do you get the answer?
Sir, it is 7,920.
Very good. 7,920 centimeter square. This much of cardboard is required for 35 participants. Yes or no?
Yes, sir.
Yes.
CSA plus 1 circle that we found out multiplied by 35. Simple. Correct.
Yes, sir.
Got it,
sir.
all of you? Have you finished with this answer?
Yes.
Yes.
Good. Now, the next figure is going to be a right circular cone. Okay, so we will need pi r L. Yes, pi r L and then pi r plus L as the total surface area. Fine. I will show you. Right now, just a minute. Cone. You know a cone shape? Yes.
Yes, sir.
Right. We know a shape of a cone. Now I'm not having an exactly conical shape with me, but something like this appears a cone. You know that our birthday wala cap rehta hai. Something like this is a conical shape. Yes or no?
Yes, sir.
Right. So now for that cone, see that cone is actually a curved surface and it has got a slant height. It has got a slanting height. I'll show you while I'll draw a figure and show it to you. If I'm talking about the cone would be something like this. Yes or no?
Yes, sir.
Now see, it's very important, children. Pay attention. This is the height of the cone. This is the radius of the cone. Yes or no? Of the base. This is
Yes,
the
sir.
radius of the base circle. This is the height of the perpendicular, and this is the right angle triangle. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Then this L would become the hypotenuse of a right angle triangle, the slant height of the cone. And that L square would be h square plus r square. And that is why your slant height would be under the root h square plus r square. Slant height would be under the root h square plus r square. Can you understand that?
Yes, sir.
हाँ. And now the curved surface, if the cone is hollow cone, जैसा मैंने अभी तुमको दिखाया था, अपना hollow cone जिसमें हम लोग भेल वगैरह लेते हैं, parcel, that hollow cone. So if the cone is a hollow cone like this, if it is not having anything at the base, only a conical shape, then that would be only curved surface area. And that curved surface area's formula is pi RL. That is pi into radius into slant height. If slant height is not given, we will first find the slant height and then use the formula pi RL. Okay? Yes or no?
Yes.
And when it is a complete cone, there will be one circle added to it, pi RL plus pi R square. Yes or no?
Yes,
Yes,
sir.
sir.
Right. So see what now? So see all of you. Okay, that formula is right now not important to us. How did we come to that formula? We will just write about that. Write down. Draw the figure for a cone and write down these things. We will solve the sums tomorrow. Today just write down about the cone. This is figure number 4. Figure number cone. 4 is cone. A cone is formed by rolling. It's formed by rolling a part of a circle. Some part of a circle is rolled to get a cone. It has a perpendicular height. It has a perpendicular height h as well as a slant height L. Do that, we'll write like this. Draw the figure. The height h, radius r, and the slant height L form a right angled triangle according to Pythagoras theorem. I square is equal to I square plus R square. This. And therefore, so find out the value of L and further that write down. Out surface area of the cone is equal to pi r L. Curved surface area of the cone is equal to pi r L, where L is equal to slant height. Yes or no?
Yes, sir.
And total surface area, if it is a closed cone, will be what then? CSA plus one circle at the base. Yes or no?
Yes, sir.
Is equal to pi r L plus what, children? Pi r square plus pi r square. Finish it off. Our meeting is going to get over. Is equal to pi r common r plus L. Simple. Pi r common r plus L. That is going to be the total surface area of the cone. We'll solve the sums tomorrow. Yes or no?
Yes.
Yes.
Complete it all of you.